All right. So let's see if I can twist some arms on this MGIG conversation. I know some of you said you're not sure. This is not intended to be a sales pitch, but I do see, just more and more traffic kind of coming through. And so this was a little test that Cisco put together. So you can see down bottom, we have 3 of these IX chariots. Have you heard of, I think it's Ixia, the traffic generator, it's traffic generator software. So we got 3 of these connected at a gigabit. So you've got basically 3 gigs of source content material that we can push across the wire. We've got a connection to this 9800 controller at 10 gigs. And then we've got a 5 gig connection down to, I believe this was a 9130, connected to some clients, both 5 gig and 2.4. So, as we've seen and talked about, to MGIG or not to MGIG, that is the question. So, a gig is still a good amount of traffic. We know that to be the case. But as with all things technology, what used to be good starts to become less good over time, it seems. So they put this test together and started pushing traffic, and these were the results. So like I said, 3 of these laptops connected at a gig, so we can offer 3 gigs to the environment with 3 over-the-air clients, just 3. I mean, that's kind of the fun part here to me. We're just trying to pull down information as fast as possible from those with those 3 clients. UDP traffic hit 1.8 gigs, and they actually showed another one where it got to 2, and then TCP, which was a little more, stable, we pulled 1.2 gigs. So that is the official test results. You really can drive more than just a gig with each of these. So they gave some graphs here that said, okay, we kind of followed this test up where we were seeing 1.5 gigs with an MGIG switch in place, and then we put a gigabit switch in the chain to kind of be that bottleneck that we would typically see with a gigabit switch, and it dropped that traffic down to 870 megs. And so this is where we find that that MGIG switching is really needed as that backbone connection. I think of what we've done with switches over time, right? We've shifted to 10 gig backbones because I've got probably 48 ports. Most of those are connected, maybe 40 some devices or something like that connected, and having a 1 gig link back to my core switch just didn't seem like quite enough. I needed a little bit more juice there to push that amount of traffic. Well, we're starting to see that on the wireless side, right? I might have 30, 40 clients connected to an access point, and having a 1 gig backbone back to my switch is starting to be that bottleneck here. And then they make the final point. This was with Wi-Fi 6. Wait until we get to 6E with 6 gigahertz and those 160 megahertz channels. So this is not even the cream of the crop. So key takeaways: more than gig on a single AP is possible. Wi-Fi 6E and the 6 gigahertz space is going to drive more yet. Overdriving 1 gig switch port throttles the throughput, right? We saw that drop down to 850 or 870 or so. And MGIG kind of removes that bottleneck. I will say I have my own kind of anecdotal test on this. I have Wi-Fi 6 APs at my house, some Meraki MR55s. Actually, it was like the first generation of the Wi-Fi 6 things that they did. And so, and I've got an 800 meg circuit from Comcast. Now, my firewall, unfortunately, throttles at about 500 meg. But when I do a speed test, purely from my iPhone here, so, it's a powerful device, but it's still kind of tiny, and you wouldn't expect it to do too much. I push that firewall every single time, 500 megs. My throughput is not, and that's a single device, right, going out at one time. So you can imagine as you add 20, 30 devices to an access point, and they start pushing, high throughput application traffic, we're going to start to hit that speed. Down the home stretch here. So we've got Wi-Fi 6 and Wi-Fi 6E APs that are pushing a lot more traffic. Behind that, we've got MGIG, so we can push more traffic from the AP to the switch. Well, I've got 2.5 and 5 gig ports coming into the switch. That kind of, we've been doing 10 gig backbones for a while. By backbones, I mean, generally fiber connections back to a core switch or something like that. But we might need to think about upgrading those. You can bond, a few 10 gig connections together, and maybe that gives us plenty. But and I've talked to a lot of you about this, but even more than the bandwidth of a full 10 gig being saturated, a lot of times it has to do just with the buffer space, right? It's not that everything flows in, all the packets flow in a nice, even, consistent stream. They jump out and they burst onto the switch. And so the switch has to, in a matter of nanoseconds, buffer all of that information before it can send it out the other, the upstream port. And so, in some cases, we're just we need some more of that buffer space basically to handle not so much full 10 gigs worth of capability, but just as more packets are hitting the switch, I need a little bit more ability to manage that. So you might see a new entrant into the field here. We've been talking for years about 10 gig, and then if you go beyond that, 40 gig and 100 gig. But there's this new entrant, 25 gigs. And you can see it's supported across the spectrum here, right? 92, 93, 94, 95, 9600. We've got 25 gig capability. And that becomes attractive for a few reasons. One, it follows this SFP28 standard, which is the same form factor as the rest of these SFPs, the 1 gig and the 10 gig. So it's the same size, same real estate that gets taken up. Kind of hard to see, but on this 40 gig, it's almost double the width. So that gives us some advantages, just in that we can support on some of these modules both the new 25 gig standard, and then maybe you just have some existing 1 gig, 10 gig connections that still need to remain in place. Well, you're going to have a hard time plugging that into this QSFP port, right? It's a different form factor. But we can support that here. You see SFP and SFP plus transceivers are supported 11025. So in your environments, when you're in kind of a mixed scenario, but we're trying to get some of our backbone upgraded to 25 gig, we can use these network modules to facilitate that. The other thing is we got to talk about the migration, because if you upgrade your access switches, and I encounter this with a lot of organizations, I'm upgrading the edge, the access layer that services my APs maybe, but I'm not necessarily ready to upgrade my core. So, well, what do you do there? Because you've got 10 gig at the core, but you want to go to 25 gig at the access to kind of future-proof a little bit, right? Well, Cisco introduced this because it's the same form factor, and I don't know if I've seen this before. This is a dual speed SFP. So it is a 10 gig and a 25 gig. We've got short haul and long haul options for that. What that's going to allow you to do is you do the access layer and you convert that over to 25 gig, but it'll still communicate to your core layer at 10 gig. And then fast forward a couple years and you're ready to upgrade your core. Well, great. Then we'll install 25 gig at the core. And now all of a sudden you've upgraded your backbone speeds to 25 gig. So it kind of eases that migration. They make the point here, right? From 10 gig to 25 gig, because you don't have to do everything simultaneously. Maybe it's reverse. Maybe you're upgrading the core and you're ready to, make that investment and you want to prepare for the future 25 gig, but you're not ready to do the access layer. Well, we can do this kind of dual speed operation. So I wanted to, throw that out there. Obviously, 40 gig and 100 gig, if I go back to this one, is still available if you really expect to, push the envelope on some of this traffic. And there's a case to be made in certain circumstances. Maybe that's the right call. But we also have this kind of interim or intermediate, maybe I should say, option available as well. And I think from a migration perspective, makes a lot of sense.